Example 5. Find the limits A, limit x over cos 1 over 2 pi minus x as x approaches 0. B. Find the values of x at which fx equal to arc sine x plus ln x over x squared minus 1 is continuous. So we solve for the part A. Step 1. Understand the problem. So in part A, we need to evaluate the limit of trigonometric function, limit x over cos 1 over 2 pi minus x as x approaches 0. Step 2. Devise a plan. To solve this limit of the function, we need to apply L'Hopital rule since x approaches 0. X over cos 1 over 2 pi minus x is equal to 0 over 0. So, we can apply the L'Hopital rule. Step 3, we carry out the plan. Okay, we rewrite the function, the limit of the function, and we apply the L'Hopital rule. Okay, where L'Hopital rule, we need to differentiate the numerator and differentiate the denominator, and then take the limit. Okay, when we differentiate x, we got 1, and we differentiate the denominator, which is cos 1 over 2 pi minus x, we got cos x. Then we plug in the value of x equal to 0 into the function, and we got 1. So 1 is the answer for this limit. And step 4, look back. We can check the answer geometrically by plotting graph of the function using Desmos or graphing calculator application. So this is the graph for this function. By referring to the graph of trigonometric function above, we can see that as x approaches 0, okay, when x approaches 0, the value of fx gets closer to 1. Okay, this is 1. Hence, prove that limit x over cos 1 over 2 pi minus x as x approaches 0 is equal to 1. Same with the answer that we got just now. For the part B, step 1, understand the problem. We need to find the value of x at which fx equal to arc sine x plus ln x over x squared minus 1 is continuous. Okay, we need to find the value of x. Next, step 2, devise a plan. The fraction will be continuous at all points where the numerator and denominator are both continuous and the denominator is non-zero. We need to make sure that the numerator and the denominator are both continuous, and the denominator is non-zero. So the fraction or the function will be continuous. Next, we carry out the plan. Since arc sine x is continuous everywhere and ln x is continuous if x more than 0, the numerator is continuous if x more than 0. Okay. The denominator being a polynomial. Okay. This is polynomial. It's continuous everywhere, so the fraction will be continuing at all points where x more than 0 and the denominator is non-zero. Thus, fx is continuous on the interval 0, 1 and 1 to positive infinity. For the last step, look back. This function is continuous at every number where the numerator adds more than 0. Okay, the numerator adds more than 0. And the denominator is non-zero. For the polynomial function, in the denominator, when x equal to 1, the denominator is 0. So the function has discontinuities at the point of x equal to 1. Hence, prove that f(x) is continuous on the interval 0 to 1 and 1 to positive infinity. So this is the answer for this part.